This section is on single replacement reactions and predicting their products. Single replacement reactions are also known as single displacement reactions in some cases. It's the same thing, just a different name. When one element replaces another element in a compound, that is considered a single replacement reaction. In order for this to be a single replacement reaction, a couple of things must be true. One thing that must be true is you have an element on its own as a reactant in addition to a compound. Usually the element that is on its own is either a metal or a halogen. We'll talk about both cases in this video. Many of these reactions will take place in solution, and the general scheme is A plus BC will yield AC plus B. So you can see from this graph that the A and B will switch places in the product. The A will then be combined with C, and the B will be kicked out on its own. The same thing is true in the second case. This is if you have a cation replacement, and this is if you have an anion replacement. Remember, a cation is a positive ion and an anion is a negative ion. If the element by itself is a halogen, then it will replace the second part of the compound, which is likely to be a halogen also, and kick it out by itself. That is how single replacement reactions work. An example would be silver nitrate and copper metal, forming copper 2 nitrate and silver metal. AgNO3 is silver nitrate, and if you add to that copper metal, those are your reactants. The copper will replace the metals. Metals replace metals only, and then it will kick the silver out by itself. So then you will have silver by itself, and you will have copper, and since this is a 2 charge and nitrate is a 1 charge, we have to have 2 nitrates in the picture here. Now, when you go to balance your equation, you will have to put a 2 in front of the silver nitrate to get 2 nitrates and 2 in front of the silver on this side to balance your equation. So remember, if the element by itself is a metal, it must replace the metal in the compound. It cannot replace the nonmetal, and it will kick it out by itself and then form a new compound. Here's an example of what this reaction looks like over time. Literally, when you put a piece of copper metal inside silver nitrate solution, eventually silver will start to form on the outside of the copper wire, and your solution will start to turn blue due to this copper 2 metal ion. In Hollywood terms, this might be titled the switch. Example might be Brad Pitt and Jennifer Aniston. Angelina Jolie comes on the scene and switches with Jennifer and marries Brad Pitt, and Jennifer Aniston is kicked out by herself. Tips for single replacement reactions when you're predicting products. Remember that metals will always be first in a chemical formula, or they will be by themselves. For example, in the equation that we just looked at, AgNO3 plus Cu, you can never have Ag and Cu come together because they are both metals. So the metal will always replace the other metal, not combine with it. That is very important. Also remember that nonmetals or polyatomic anions will always be second in the chemical formula. You never put them first. So likewise, in this same reaction, I would not have NO3 in front of the copper plus the silver by itself, because the metal must always go first and the polyatomic ion must always go second in the formula. Types of single replacement reactions. When you're dealing with cation replacement, that is the replacement of one metal by another. An example might be for lithium to replace gold. So we have gold 3 chloride in this case and lithium by itself. Since lithium is more active than gold, it will replace it, and it will kick gold out by itself. So then the lithium will become paired with the chlorine. Now, be sure that you check your charges here. When lithium is by itself, it has a charge of 0. But when it forms a compound, it has a charge of 1. Chloride is -1. So in this case, you don't need any subscripts. Okay, since chlorine is -1 here, we know that gold must be +3 here. However, when gold is by itself in a formula, its charge is 0. So when you have a replacement with a metal or a cation metal, you will actually change charges in the process of going through the reaction. In this case, to balance the equation, we would need a 3 here for the chloride, and then we would need a 3 in front of the lithium to make sure that the equation is balanced. Another type of cation replacement is the replacement of hydrogen in water by a metal to produce metal hydroxides and hydrogen gas. So if I had a metal like sodium and I put it in water, this is a type of single replacement also, because even though the hydrogen is not a metal, sodium is more active than the hydrogen and so then can kick it out by itself. However, when it does this, it forms a very specific product, a hydroxide, and the hydrogen by itself will become H2 because it is part of Hofbrinkel. The third type of single replacement reaction for cations is the replacement of hydrogen in an acid by a metal to produce a salt and hydrogen gas. In this case, if we have an acid like hydrochloric acid, we could replace hydrochloric acid with zinc to form zinc, chloride, and hydrogen gas. So the zinc in this case will replace the hydrogen and kick it by itself. When hydrogen is by itself, remember it is part of Hofbrinkel, so it is a diatomic and always has a 2 there. So we would need a 2 in front of the hydrochloric acid to balance the equation. Now, to determine whether or not any of these reactions will actually occur, you need to consult the activity series. The activity series is a list from most active to least active metals on the periodic table. The most active metals are at the top, the least active are at the bottom, and they are ranked in order. You'll also see that hydrogen is put in here for reference. The way that you use the activity series is if the element that is by itself in your equation is above the element that is in the compound, then it will replace it. If the element that is by itself is below the element in the compound, it will not replace it. So let's look at one of our examples. Let's say that we look at zinc and hydrochloric acid. So we are looking for the element by itself is zinc. Here is zinc on the activity series. Since zinc is above hydrogen, which is right here, it will replace it in this reaction, and then the hydrogen will be kicked out by itself, so we'll end up with zinc chloride and hydrogen gas. If zinc were to be below hydrogen, this reaction would not work. It would not take place. So for example, if I had silver plus hydrochloric acid, silver is not above hydrogen, so this will get a no reaction. The reaction will not occur. That is how you use the activity series for metals. So when you do the assignment over this particular section, you need to consult the activity series to see if the metal by itself will actually replace the metal or the first element in the compound. If it will not do that, then you need to write no reaction as your answer. Now, the second type of single replacement is called anionic single replacement. And this is because you usually, in this case, have a halogen that might replace another halogen. Okay, that's the only type that we are going to talk about are the halogens. They are considered anions in compounds because they are negatively charged, and they are in group 17 or 7A on your periodic table. If the halogen by itself in the reactants is above the halogen in the compound, it will replace it. So for example, if I have a reaction that is Cl2 plus NaI, and I want to see if this reaction will actually occur, I have to consult my activity series for halogens. Since chlorine is above iodine, so the element by itself is above the element in the compound, it will replace it. And I will end up with NaCl, and the I will be kicked out by itself as I2 because it is also part of Hofbrinkel. So I will need to add a 2 to both of those locations to make sure my equation is balanced. Let's do a couple more examples. So another example of cationic single replacement would be lead plus copper 2 chloride. In this case, the lead will replace the copper and kick it out by itself because lead is above copper on the activity series. Whenever you are dealing with a transition metal and you may not know what charge it becomes, it is a good idea to use and assume that it's a charge of +2. Okay, so remember that metals, when they are on their own, they have no charge. So it goes from a 0 charge to a +2 charge, which means in this process it is oxidized. Oxidized simply means that it has lost electrons in the process of this reaction. Copper, however, started with a +2 charge and ended with a 0 charge. So it has actually gained electrons in this reaction. So copper is what we would say is reduced. If something is reduced, that means it has gained electrons in the process. Okay, and more on that later. For anionic equations, you have to look at the element by itself and then the corresponding element in the equation. I know that F and Cl are both halogens, so those are the ones I'm going to focus on to see if whether they will replace. Since F is above Cl on the periodic table, it should replace it and kick it out by itself. So I should have Cl2 plus NaF. And then I would go back and balance my equation here and here. If you have any other questions, please reach out.